Good day, this is Luis Angela C. Anino, and I will be discussing about simplifying radical expressions. To understand this lesson better, you have to acquire the skill on the rules on the fundamental operation of integers. Simplifying radical expression has four properties, and you have to know these following properties, which is product property of radicals, quotient property of radicals, addition property of radicals, and subtraction property of radicals. In product property of radicals, it states that for any real number a and b and any integer n greater than 1, the nth root of a and b is equal to the nth root of a multiplied to the nth root of b. If n is even and a and b are both non-negative, or if n is odd. Consider these following examples. Example number 1, square root of 16. First is we have to factor this into its squares. So we have square root of 4 squared. Then simplify. So it will become equal to 4. So square root of 16 is equal to 4. Next example is square root of 32 x to the power of 8. So the first thing to do is to factor it into squares. Then apply the product property of radicals. Then next is to simplify it. So square root of 32 x to the power of 8 is equal to x to the power of 4 times 4 square root of 2, or 4x to the power of 4 square root of 2. Example 3. Cube root of 27 y to the power of 12 z to the power of 7. First thing to do is to factor it into squares. So it will become like this. Then apply the product property of radicals. And next thing to do is to simplify. So the answer for the cube root of 27 y to the power of 12 and z to the power of 7 is equal to 3y squared z squared cube root of yz. And that's it for product property of radicals. Next is the quotient property of radicals. In quotient property of radicals, it states that for any real number a and b cannot be equal to 0 and any integer n greater than 1, the nth root of a over b is equal to the nth root of a all over nth root of b if all roots are defined. Consider these following examples. Example 1, square root of 27 over 3. So first is we need to apply the quotient property of radicals. So we have square root of 27 over square root of 3. Next is to simplify. So square root of 27 divided by square root of 3 is square root of 9. And square root of 9 is equal to 3. So the answer is 3. So the answer for number 1, which is square root of 27 over 3, is equal to 3. Number 2, square root of x to the 6 over y to the 7. First is we need to apply the quotient property of radicals. So it will become square root of x to the power of 6 over square root of y to the power of 7. Then we need to factor it into squares. So we have x cubed all over y cubed square root of 2 and multiply it by square root of y, both numerator and denominator. So it will become x to the cube square root of y all over y to the power of 4. So square root of x to the 6 all over y to the 7 is equal to x cubed square root of y all over y to the 4. Example 3. Square root of 3 minus 5 all over square root of 3 plus 5. First is we need to rationalize the denominator. Multiply the numerator by the conjugation of the denominator. Next is to apply the quotient property of radicals. Then factor it into squares. After is to simplify. So square root of 3 minus 5 all over square root of 3 plus 5 is equal to 3 minus square root of 15 minus 5 square root of 3 plus 5 square root of 5 all over 2. And that's it for quotient property of radicals. The last two properties of radicals are addition and subtraction property of radicals. Adding and subtracting radical expressions is similar to adding and subtracting polynomials. You can only add and subtract radicals if they are similar. Similar radicals are radicals of the same order and have the same radicand. In adding and subtracting radicals, simplify the individual radicals before trying to combine like terms. Consider these following examples. Example 1. Square root of 25a plus square root of 16a. So first, we have to factor it into squares. So it will become square root of 5 squared a plus square root of 4 squared a. Then, simplify. So it will become 5 square root of a plus 4 square root of a. Since they are already similar radicals, then we can add the 2. So it will become 9 square root of a. So square root of 25a plus 16a is equal to 9 square root of a. Example 2. 5 square root of 9 minus 9 square root of 16. First is we factor it into squares. So it will become 5 square root of 3 squared minus 9 square root of 4 squared. Then, simplify it. So it will become 5 times 3 minus 4 times 4. Then, 15 minus 6 is equal to negative 1. So, 5 square root of 9 minus 9 square root of 16 is equal to negative 1. Example 3. 4 square root of a plus b plus 5 square root of 9 quantity a plus b minus 6 square root of a plus b. First is we need to factor the radicands into its squares. So it will become 4 square root of a plus b plus 5 square root of 3 squared a plus b minus 6 square root of a plus b. Then, we need to simplify. So it will become 4 square root of a plus b plus 15 square root a plus b minus 6 square root of a plus b. Then, combine like terms. So because they are already similar radicands, so we can add and subtract the numbers. So 4 plus 15 minus 6 quantity square root of a plus b is equal to 13 square root of a plus b. So 4 square root of a plus b plus 5 square root of 9 quantity a plus b minus 6 square root of a plus b is equal to 13 square root of a plus b. So that's it for addition and subtraction property of radical expression. Thank you for listening.